Okay, so we begin now. Okay, so thank you all for joining. Congratulations for the teams that they proceeded in the next part of our contest, the design phase. For me, I'm Alkiviadis Michalitsis. I am the IEEE Region 8 Student Hardware Contest coordinator for this year. And today we're going to see some analytical stuff regarding the submission that you should do for the design phase of the contest. So without delaying, I will share my screen. One second. Okay. Perfect. I think you can see my screen. Okay. So, hello again, everyone. This presentation is called Tips and Tricks for a Successful Design Phase Submission. For us, we are the IEEE Region 8 SAC, and we are organizing the IEEE Region 8 Student Hardware Contest for 2026. Currently, we are in the design phase of this contest, and so let's go to see some important stuff regarding this phase. So for me, I'm Alkiviadis Michalitsis. I am the IEEE Region A Student Hardware Contest Coordinator. Some stuff about me. I am an electrical and computer engineer, and I studied in the National Technical University of Athens, Greece. And my specialization, my professional focus, it's in AI and robotics, and I'm currently working as an R&D engineer, developing systems such as embedded systems, autonomous vehicles, and bionic architecture such as ARMS and other stuff. So this is my city, the beautiful Athens of Greece. Some stuff regarding my IEEE journey so that we get to know each other a little bit better. For me, I became an IEEE student member in 2019 when I first started studying in my university. Ever since I joined my university, I found some other members. We became IEEE members, and we founded the IEEE NTUA Robotics and Automation Society chapter so that we could organize and implement robotics projects, webinars, workshops, and so on. We had all a common interest in robotics and hardware. After that, I went to the national level of Greece, where I had the position of the section student representative for 3 years. And during these years, I had the honor to be the chair and the host of the cross-sectional, the sixth Hellenic Student and Young Professional Congress, which was held online due to COVID restrictions in 2021. After that, I went to the global level in the Region 8 area, and specifically in the Region 8 Student Activities Committee. So in 2023, I joined the Training and Leadership Support Ad Hoc Committee, and currently, as of 2026, I have the position of the Student Hardware Contest Coordinator. So regarding my committee is the Student Recognition and Publicity Subcommittee of the IEEE Region 8 SAC. We have a lot of dedicated members from all different sections of IEEE Region 8 that they are helped to establish and to create a good actions and to support students in all the region. I would like to personally thank my team, Khaldoun Taktak, who is the chair of our subcommittee, Tofik Saleni, Vera Markovic, and of course our very valuable corresponding members where they are always there to support all of the endeavors and all of the different stuff that our subcommittee is implementing. So I would like to thank Doga, Gasser, Paris, Mohammed, Qusai, and Robert, of course. Other than that, let's begin a little with some stuff that I think you already know. So what is the Student Hardware Contest? What is this SHCC? So the IEEE Region 8 Student Hardware Contest challenges all of the students of the Region 8 to conceptualize, design, and build innovative physical prototypes. It acts as a transition, as a bridge between the theoretical knowledge and the practical hardware engineering to solve complex real-world technical problems. For us, we want with this, our ultimate goal is to move out of pure software simulation and theoretical thinking and to move into physical creation, building of functional, impactful hardware devices that they can also help humanity. So a little stuff regarding the history of our contest. It's not the first year that is happening. It's happening for a lot of years. So where we come from? The previous iterations of the contest, they were called IEEE Duino. This contest for years served as a cornerstone hardware event focusing primarily on hardware solutions. It provided thousands of students across Region 8 their first exposure to microcontrollers and IoT programming. Because in many universities, for example, when we are studying, we don't have the chance to get involved very much with the whole physical and hardware stuff of our software and theoretical knowledge. Currently, from this year onwards, we are going and we are transitioning to the new rename and the new branding of the contest, which is the Student Hardware Contest. So we're building on that massive success of the IEEE Duino. We have officially rebranded it to the Student Hardware Contest. And we expand the scope beyond Arduino, welcoming custom PCBs, sensors, and complex hardware architectures. All of the previous years of the IEEE Arduino, they had a lot of achievements. I will talk about the previous one. So for the 2025 IEEE Arduino, we had the 154 teams registered to participate in our contest. And it was a massive regional engagement because out of these 154 teams registered, 130 of them, they were successfully accepted and they were eligible to participate. And from all of these 130 teams, we had teams from 21 different sections of our IEEE Region 8. Yes, yes. The finals of this contest, they took place in Poland in the IEEE Eurocon 2025. So we have to honor and to give some shout out to the previous year's winners and finalists. So the top 6 projects of the 2025, it was Team Aurora Alert from Egypt, Team Dormisense from Nigeria, Team Industronics from Egypt, Team Losys Pro from Germany, Project Embernet from South Africa, and Team ResWatch from Turkey. And the podium, the final places, it was the first place, it was ResWatch from Turkey. The second place was Project Embernet from South Africa. And the third place, it was Aurora Alert from Egypt. But coming from the past, we should also see this year's achievements that we have so far. Also for 2026, we were very amazed to see that more than 200 teams registered to our contest this year, and more than 170 of all of you were eligible to continue in the following phase, which is the design phase. This year also we have an amazing jump in numbers of sections participating. We had 40 different sections that they represent, that you represent, and currently we are in the design phase of the contest. So this year we did some minor changes to the contest so that we would make it better and also that we could help more the students and the teams to have a little more ease in participating and also submitting their submissions more correctly. So for this year we have added a technical reporting for the build phase where we introduced a mandatory 5-page technical report. And for you, you will have to document your construction process step by step so that if during the build phase the judges want to implement your project, they would know exactly how to do it so that they would see that this prototype works on their own. This year also we have a little more balanced judging. We have exactly 50% academia, 50% industry involved in your evaluation, so that so that you will have a little more fair judge evaluation in your submissions. And also another thing that I think you will be very benefited. We extended the timeline so that you will have more time in the year that this contest takes place for you to implement, to think your idea, and also to implement it later in the build phase if selected to participate in it. So a little some of the basics regarding the contest that are the same every year. There are 3 core stages of the contest. Currently, we are on the first, which is the design phase. It's the phase where all the teams they should submit their project proposals, where you should outline the problem, the challenge that you want to treat and you want to fix. You should select and to show us which are your hardware choices, which is the software that you are about to use, the algorithm, everything, and also what is your estimated initial budgeting for the whole project. After that, if you will be selected from the judges, you will continue to the build phase. So for the build phase, the selected teams, they will need to physically construct, build their prototype, their project prototype. And additionally to that, you will have also to provide the electronics, mechanical and mechatronics designs for it, so that for us, we can see that it's genuine, that it's yours and it's original. Of also, because for us, we want to see if that prototype also is working, we will need a video demo, very small, specific, so that we will see that it's implemented correctly and it's doing what it's supposed to do based on your description. And finally, after this evaluation of this phase, we will continue to the oral finals, where the up to 5 finalists, they will participate in an IEEE flagship event in person, and one representative from each team of the finalists will be supported from our team and our sponsors to participate in person and to uh, give the final pitching for them to get the final place in the contest. So some stuff that we shouldn't forget is regarding the eligibility and the general rules of our contest. These are active throughout the duration of the contest from the beginning to the end. So initially with the team structure, as you might know, the participants can complete individually or in teams up to 4 members. A team leader must be appointed as the primary point of contact. Secondly, the IEEE membership is required so that your entire team must be fully comprised of active IEEE student or graduate student members, and they should be registered in an IEEE Region 8 section, which means that the country that they are from and they are participating should be inside the IEEE Region 8 area. Regarding the originality of your project, of course, it should be genuine, it should be new, it should be something that you thought, and it shouldn't be a copy of the past or of another contest or of another already implemented project. And also regarding the support from your university, your student branch, your officers, you are allowed to be supported financially and not. But at the end of the day, the hardware and all the kind of equipment that you will use should stay at you. It should belong to you later on after the support, so that for you will be judged based on what you have and not what you give what you were given. You should own the products and the materials that you will use. Now, regarding the hardware specifications, it's good to remind you some stuff. So, regarding the microcontrollers and the sensors, of course, most of the MCUs that they're commercially available are allowed, like STM32, ESP32, Raspberry Pi Pico, Arduino, Tinsy, custom MCUs, etc. Now, a higher powered and processing devices like single board computers, for example, Raspberry Pi, they might be allowed, but for you in your design phase submission and the problem that you are trying to face, you should really prove to us the real need of this to be used instead of a lower powered microcontroller. Now, regarding the sensors, you are allowed to use any commercially available sensor, as long as, of course, you provide the pricing of it, and the use case and the need of it. And of course, it's very important to say that every pre-built robotics kit they are banned unless they are heavily modified by you, which means that for you you should make a lot of changes so that for us we will accept this idea in this project. And also military and industrial proprietary parts, they are banned with no discussion. Now, regarding some other constraints that we have put to you, regarding the physical constraints, for us, we want the physical prototype that you will bring to be portable. So for us, we want the power to be only battery powered and devices in the project to be powered only via the main battery power plant. Uh, for that also, if you're gonna develop your own battery management system, you might get additional points in your evaluation. Regarding the sizes and the overall dimensions of your project physical prototype, we have set a limit of 30 square centimeters, 30 by 30 by 30. And of course, we have set a maximum weight of 2 kilos, unless the problem you are trying to solve requires something way heavier, and also the overall materials that you will use have a lot of weight. Um, for the uh, for the questions that you are doing, I will reply to you later. And now regarding the software and programming rules that we have set, every language is allowed to be used. And regarding the libraries, you can use open source libraries, but for us, we will have to get some kind of proper citation and proper documentation so that we will be able for us to promote them to the judges that they will evaluate you and to get to know exactly what you're implementing in your software. In the 2026 year is not possible to not allow AI generated code, not even a little. But for us, the only thing we request from you is that every piece of code, every line of code that gets generated or that you provide to us to be well executed, and also for you to understand it completely, because you might be evaluated based on how you describe your code in your uh, submission packages later on. Regarding the communication between the different interfaces, sensors, boards, and all kind of stuff, we are allowing different kind of communication protocols. The basics that we are mentioning here is the I2C, SPI, UART, BLE Bluetooth, Wi-Fi, LoRa, RS422, RS485, and RS232, which I think it would be a little redundant based on the voltage that you will play. Uh, at the end, we also have to mention the source code submission. For the source code submission, we want the complete one. We want every kind of function, class, or whatever you implement to be submitted to us so that the evaluation will be correct. And of course, this part will be more analyzed in the build phase webinar that we will have following the announcement of the teams that they pass to the next phase. So, as we may have said a lot of times now, we are currently at the design phase of our contest. And as it's the initial phase of the contest, you, the contestants, you should plan, simulate, and also justify your proposals to us. You must submit a comprehensive package explaining your idea, and you can split the complete submission into the following kind of categories. So for the submission package, you must include a package or a sub-package that describes the problem statement and the solution overview, a list of intended hardware components that you might use in your physical prototype later on, a software design, the complete logic algorithm and with block diagrams and flowcharts, and of course the preliminary bill of materials, which is known as BOM, and cost estimations. This step is very, very crucial because uh, in the future, for example, you're going to participate or you're going to be part of a company. And when you will have an idea, you will go to your technical director and you will want to suggest to implement or to build something. For you, you can't ask for kind of funding or kind of budget from your technical director if first you will not do the correct research and you will not prove that all your endeavor and your trial will be well worth it for the company. So that's for us what we want in the design phase. Like in real life, we want you to prove to us your idea before we even go to the build phase of the hardware contest. So let's see some stuff about that. So regarding the design phase, what are we asking from the teams? So the teams they must submit the project ideas for evaluation before building a physical prototype, as we said. And we have the following three steps. First of all, the team should plan, should think regarding their idea, and should define the problem. What are the targets which are the targets? Who will use the product? What are the technical constraints that you will find in front of you or in the future? And what performance do you expect before you even choose the components? So for us, when we want to plan something, we want to put some baselines. So for us, we say, worst case scenario, we want to do this. So during your planning and your idea, for you, you should think, what is the thing that your project wants to do, even if everything goes wrong. And based on that, you will build on top of it. Regarding the design and the simulation, you should show how the hardware and software will work together using some kind of diagrams or flowcharts, simulations if possible, or calculations. If you can't show a simulation or you can't implement one, you can give some mathematical formulas regarding, for example, the power consumption of your system, which is specified based on the voltage and the amperage that your system is requiring. So after the idea and the initial designing, then we go to the justification. Why is this needed? So for you, you will have to explain why each major decision that you took is reasonable, feasible, and compliant with the contest rules. Which means that, for example, if you select a specific microcontroller than another, for you, you will have to tell us exactly why you use this one. Maybe it's because it's less inexpensive, or because it's more powerful, or because it has more general purpose I/O, etc. For you, you have to have a reason that you select something. And for us, we want to see exactly how you think regarding your selection. You might also say that it was the only available that existed there. It's a valid reason. Sometimes in a company when there are not a lot of choices, we take the only one that we have and we make it work. So regarding the deliverable, we need a comprehensive document explaining the project idea, the intended hardware, the software logic, and the preliminary cost estimation. So a, ma a basic estimation of the overall costs of your system implementation. And why we need all of this? The goal is not to reward the longest proposal or the most amazing one regarding the components or the complexity. For us, the basic thing is to identify ideas that are clear, original, feasible, and ready for the build phase. So for us, we want your ideas to be well thought after before you even send it to us, so that during the build phase, for you, it will be the time that you will need. It will be easier for you to implement based on your basis and your baselines, other than rethinking again the submission and the idea of your project. So regarding the submission package now, every required section of this answers a different kind of question for the judges. For example, uh, as you might have seen in our design submission guide, we have the following kind of sub chapters. One of them is the problem statement and solution overview. For you, you have to say to us and to describe to us what problem are you trying to solve and how does your proposed device addresses it. So for you, what exactly are you trying to fix, and what are you doing differently that hasn't been done yet? Regarding now the intended hardware components that you might use, you should say what kind of physical parts that you will use and why are these specific and suitable for your design implementation. Now, similarly, exactly to the hardware, but on software, for your software design, you should explain how your system will read the data, how it will make decision, what will be the outputs, and how it will control based on different kind of situations, and how it will handle possible errors. So for example, for us, when we implement an algorithm and a logic, we always should check for an exception. For example, if I say I read blue, red, green, and the color that I get it's black. If I haven't implemented a specific default like action for a different color other than the three basics that I'm expecting, my program will never stop when I read this color, and that might be fatal for the whole system if for example, it's a moving system. So other than the software design, and the final thing is the preliminary BOM, bill of material, and cost estimation. And here, what you have to reply to us and what you have to describe is, can the project realistically be built within the 200 USD, United States dollars, that for us we have set to you as a budget limit? And why all of this? Why for us do we put this kind of limitations to you? A strong ambition is supposed to be balanced. For you, you should explain your idea, and for you, you should show us exactly how you think of implementing it as engineers. How are you trying to compact and to solve the problems that we put to you based on the restrictions and based on the restrictions of the challenge that you're trying to fix, and also everything in real life, even in companies, even in universities and stuff. It has to do with the cost feasibility. Uh, a good engineer is the one that does the same thing less inexpensively than one that does it expensively. That's a fact. It's not something that I'm saying now. So, starting with the whole submission, for us, we want to see a professional proposal document. So for us, we have set it some kind of baselines for your documents to be in a specific form, so that it will be easier for the judges to evaluate it and to not see, for example, big fonts or big images and so on. So before even you go to the technical content, you should make sure your submission is clearly identifiable and easy to review by the evaluators, which are judges. Okay. So the first page of your submission package, of your PDF, of your document, it should include your project title, the name of your project, of your system, the team, the name of your team, the IEEE section that you are from, the IEEE student branch that you are from. For the teams that they don't have a local student branch, or they don't they are not in one, they can just write no student branch available. And of course, and very specific to all the implementation and all the submissions that you will do in the future, all the full names of all the team members, and for them to be correctly based also on the submission of the teams that you did in the first step of registering to this contest. It's very important for us to see that all the team members that for you submitted in the contest, they are described and written in your proposals. Because for us, we want to see that all the people that worked equally, and also all the people, and also we want to see that we have at least the same amount of people. If we have more, this is disqualification. So please don't change any members of your team, because it will be very difficult for us to understand what's happening, and we will have to get into communication with you. And maybe if we see that a lot of you is doing it, we will try to fix it before the finalization and the deadline of the design phase submissions. But please don't change the team members of your team. It's very important for you to stay the same. Now, regarding the formatting of any kind of document that you will submit, we have set some specific baselines. So for the main title, we want a specific font, which is Times New Roman. We want it bold, and we want the size of the font to be 24 points. For a section heading, we want the type of font to be bold and Times New Roman also, and to be 12 points. And so on for the body text, the regular 10 points, and the space in between the lines to be 1 or 1.15 based on your selection. And of course, we want to put a limitation, limits spacing up, down, left, and right of a paper document. So for us, we have selected for it to be 1 inch or 2.54 centimeters. What is the reason of all of this? As I said before, is to standardize the formatting to help the judges in evaluating your submission so that they compare your proposals fairly and they will focus on the engineering quality instead of searching for missing information or for a lot of or big documents and so on. It's very important the identification and formatting to be simple so that for us we'll have a clear image and a clear picture of the team. You should make the proposal look serious and also complete. And it should also align with IEEE professional standards, which means for you at least use the same formatting that we have said to you, and also the expressionism and the phrases that are used to be a little more formal. Now, some help that you might be needed. You can find your student branch in the following link. This kind of slides they will be sent to you, so you can find it in case you haven't found it before or that you might think that it's wrong and you want to fix it. Now, for the first part, also mentioned in our design phase guide, which is in our website, we should talk about the problem statement. For you, you should prove that the problem exists. So what's the point of trying to implement, to fix, or in general, to do something if there's no need to? So for us, we need from you to show us exactly what is the challenge, the real challenge that you are trying to combat and to fix. So for you, you should, for example, to not begin with, we will use an ESP32 microcontroller. This is a little basic. For us, we want you to begin with the need. What is the real need that you are trying to fix and that you are trying to give us? So what is the current need? What is the user and the current limitation? So as I said before, we begin from a baseline. What is the current problem? For example, what is happening today? Describe the current process and the manual method. For example, if we don't have an automation or a microcontroller, it's manual. Someone does it, a human does it. Is it inefficient? What is the cost that is created by it? And also the time that is spent. And what about the risk regarding the health and regarding the tiredness and the life potentially of the human? Of course, for something we say, we should have evidence. So regarding the evidence, we would prefer if you use some kind of statistics and numbers. So if possible, we would like you to give us some kind of time or time spent, time needed for the manual before your creation is implemented, the error rate of this procedure that is being done before your implementation, the energy used if we have this kind of example, the distance, the accuracy, failure rate, or response delay, and etc. And also, why do we really need your implementation? You should explain why this problem deserves a hardware solution and who benefits from solving it. So for you, you should implement something that is meaningful for us, for all of us, not only for us, for all of the people. Okay. So I have added a good example direction here. It says the current manual process takes X amount of hours, creates Y amount of risk, and lacks real-time sensing. Our system targets Z improvement. So for us, we put some metrics and we put some kind of statistics so that we see the benefits of our implementation when we want to do something. And someone might ask, why do we all need this? The judges can judge based on how impactful is what you make. So if they understand the real starting point, the baseline, as we say here, and the gap your project is trying to close, it will be much easier and you will be much benefited during the evaluation. When we implement an idea, when we think of an idea, before implementing, we should think of the restrictions and the problems that we will face before we even implement. So we should, for you, you should define the constraints and the performance targets that you want to acquire. So for you, you should set your own baselines. What is the list? Which is the worst case scenario that for you want to be capable of having, and also what are the constraints that are existed already. So regarding the technical constraints, an example might be this is a battery powered operation. So for example, you don't have unlimited power in the battery, so this will be recharging or even changing of the battery if it's not rechargeable. Outdoor humidity, heat, dust, or vibration. This might create problems during the movement of your system, during the electronics. The lack of insulation might be a problem, for example, here. Sensor age and accuracy limits. So sometimes the use of a single sensor might have a big error if it's not used correctly. So usually you might need to use two so that you take two references and to create a better one. Size and weight limits. As we said before, for us, we have already put some kind of limitations for you in the size, unless your challenge and the problem you try to fix and to solve requires otherwise. But also you might have limitations in the real world scenario where for you, for example, you want to make a robot that wants to go inside like a cave in a mountain. If you make the robot too big, it might not be able to enter at all. So for you, you have to think of it and you have also to present it to us. Regarding the communication or the latency limits, that's a good point. For example, for us, when we use some kind of sensors, for us, we implement some kind of methods and algorithms to retract and to get the data from the sensors that we read. So during your system architecture and your algorithms for you, you should think a little how much and how often you want to get some data for your operations. And you should also, all of this, you should also show them to the judges. Very big concern. Safety and reliability requirements. The worst case scenario for us is to harm ourselves. So for us, we want everything to do if there's a possibility of someone getting hurt, for us to be able to avoid it. So for us, if that's the case, we should reference it and we should reference exactly what are the methods to avoid getting hurt or to create an accident or a problem in general. Now, regarding the performance targets, this is the part where for us we put our estimations, and these are the parts, for example, when we're in a company that are the selling points, let's say, to our technical director, to why we want to do this, what we will win, what we will get from it. So, for example, it might be something like a reduction in power consumption, like, for example, reduce the power consumption by 30%. It could be to detect events within 2 seconds. So for you, for example, you might have a problem where you don't know what is happening and you want to find a solution to detect when it's happening. So for you, you create a device that takes samples, and for you, you get exactly the idea based on the samples that you get when an event is occurring or is happening. Operate for 8 hours on battery. So this might be, for example, your goal is to make something to be as power efficient as possible, that a single battery might last 8 hours. Because, for example, you might not be there to charge it every time, or it might be remotely, or it might have constraints regarding how easily or difficultly the battery is put or removed from the system, or how difficultly it is to charge. Maintain cost below 200 USD. Yeah, that's the basic target of the whole implementation. This should be your limitations in general. When you want to think of hardware, you will say, okay, I will not take the most expensive one because I can't buy it. I don't have the amount of money to do it. So for you, you will have to think other ways to implement your idea, or to think other ways with different kind of system architecture on how you will do the same with different uh, physical prototype. And another goal, it would be also to improve accuracy or response time. For example, if I have something that makes an action and it's inaccurate, for us, we want to make it as accurate as possible. Of course, as in life, the same thing goes into hardware and especially in real life. So every design has trade-offs. We can't do everything with one thing. So for us, we should sometimes contrast and to select. We want something to be more expensive and less accurate. Do we need this kind of accuracy? If not, it's good to be less expensive. What is the end goal? Who is the end user? Important stuff that you should also show us. Battery life versus sampling rate. What is more important for us to need to charge it every 2 hours or to get as much samples as possible, if that's the case? Size versus feature set. Do you want something that will do a single action and it will be tiny, or something that it will be big? It can do 1,000 things, and it will not be able to fit in most cases. If we have a big space, if the use case it's a big space, we don't have a size limitation. But for example, if it's a small space like the cave I said before, we want something to be small. So for us, we would have to find ways with less actions to do what we do, what we want. Local processing versus wireless communication. This is a nice thing. We will create a system that has only one processing power or two. We will create something that gets the data from a wired sensor or from a wireless sensor. These are some kind of stuff that it might consider you during your implementation and your design thought. So the proposal becomes credible when the team shows what must be achieved and what limitations the design must survive. So for you, you will have a better evaluation and you will get the full focus of the judges when you will present them something where it's well thought after. We want the starting, the ending, and the middle. What's happening in the middle is the most important. The problems and the errors happen in the middle. So for us, we should think when we implement what might go wrong every time we develop something. Regarding now the solution overview, you should explain how you solve it. You explain the engineering idea. So after defining before the problem, you should describe how your proposed device system will solve it. So what will it do? You should describe the device functions clearly, what it senses, what it processes, and what physical output or decisions it produces. So for you, you will have, for example, to explain what are the sensors used, why are they used, what are the data that they're taking, why are they taking them, how much they're taking them, and so on and so on. You should analyze what is the sensing and what is the action, the output, what we want to do based on the sensing. Why this approach? Why did you select this over something else? You should justify the solution compared with a manual process. For example, if for me I want to clean my house, let's say for example that I don't have the time, that might a robot mop to be better for me, for example. So for you, you should justify the solution compared with manual processes, software only ideas, or more expensive existing systems. So for us, in general, when we are proposing something, we usually compare it with the things that and the other options that we might have if we give more money. So sometimes if we do it more inexpensively, might be best for us, or we might lose some kind of features that we don't actually need it either way if we did it more uh, like advanced. So this is a use case scenario that you should show to the judges. Why is innovative? Why what you say and what you thought is something that no one else has ever done, or for this specific problem that you try to fix, why no one has done it the same way as you exactly. So even the software can be different. It's different. You can have the same hardware and the same basic idea of the hardware that you want to implement, but if the software is different, the implementation is different. So it's like an innovation. So you should highlight what is new. Low cost design, for example. You used less sensors to do the same thing. It's a low cost design. Energy efficient. You created the battery management system that is handling the battery charge better than one that you might buy from the from the commercial market. That's a big bonus. Smarter control logic. You might create algorithms and to create a processing kind of thinking that it might be more advanced than a basic implementation that is being implemented right now for this problem. Local impact. Who will use this? How many people it will affect? What is the big picture here for the main good? Let's say, okay, and the environmental benefit, if that's what it does. Some recommended sentence structure that I added. You can say, for example, our system uses this kind of sensors and this kind of controller to detect this kind of condition statement. Okay, and you decide the logic, and then you activate something, which is the out, achieving this specific thing, which is the target. Okay. So the overview connects the problem to the implementation. For us, we want to think if what we're doing is worth it. And that will also prove to the judges for you have thought exactly what you want to do and why you do it, and that will be much easier for them to evaluate you correctly. So the judges they want to see a project as complete system rather than isolated parts. So for you, you should prove to them the complete picture, not this sensor is used for this. You should say this sensor is used for this because we have this problem and we will use these sensors and so on and so on. Now, regarding the intended hardware components, you should justify every part. It's like we have in our design phase guide that you might see later if you want. The hardware list should explain the function, the compatibility, and the cost and the reason of selection. So if a sensor you just add it because you have it and you will not use it, it's not a very good idea to do it because it's something redundant and it's something that it's adding cost, weight, complexity, and so on. So, for example, for you, you might say, for example, the component it's my microcontroller or my microprocessor. What is the function that this thing is doing? It controls the system, for example. Not that general like that, but yes. And why do we use this part? For example, it might have enough inputs and outputs. It can have low power cost. It can support multiple communication protocols. And for example, you can take some kind of interfaces and nodes on each thing. For example, MCU processor. Okay, this has general purpose I/O. It has analog to digital converter, I2C, SPI, UART, etc. You say you give some highlights um, on the specifications and the specs you want something to have. Regarding the sensors now, why do we use them? Okay, we use them to collect input data. Okay, that's good. Why this specific part? This thing it can have a correct range based on your implementation. It can have the accuracy that you need to do what you do. It could be environmentally better than something else, or to be something that is specific for the environment, for humidity or whatever. And availability, for example, I wanted this, they had this, okay, we will use this and we will change some other stuff. This is also acceptable. It happens in real life. And for example, for this, you can say analog or digital protocol. Uh, it's a highlight of this kind of sensor. It's an analog sensor, it's a digital sensor, and so on. Now let's go to our outputs. What are the actions, the actuators, as we say? What is the function of an actuator? To move or to do something. Okay, so function create physical response. If you use, for example, a DC motor in your implementation, you can say, I use it to move a fan, to do something. Why do we use this thing? Because based on our voltages and our restrictions of our other hardware, we want this voltage logic. These are we don't want for it to draw a lot of current because we have a small battery. We have a driver issues with another one, so we use this driver. It's the piece of firmware that connects the hardware with that connects the microcontroller with a piece of a sensor. It's the thing that has libraries and so on. I'm just so for this you can also reference for the interface and the nodes that it's, for example, if it's a DC or another kind of motor, it supports pulse width modulation, which is the kind of control of the speed. You can have a relay for you to use high voltage to open it and close it, or for you want to avoid using high voltage, so you use a relay and you control with low voltage the high voltage output. It has a better driver for our microcontroller. That's okay. It's a display. It's an output also. It's a thing that the user will interfere with. And lastly, let's go to the power system, the part of our system that it's powering it. So there are not maximum words in general. Okay. So the function of the power system is to supply energy. Okay, good. Why we select this specific part? We select it because this battery type goes along with this battery mode, and we want to have a battery or a voltage regulator, and these batteries are better for this, and we want to have protection, efficiency, and so on, so on. Okay. A lot of stuff we can do with this. For example, here you can say battery regulator, BMS, battery management system, and so on. So the key idea of all of this, do not just write ESP32 and just let it there for us to understand why you use it. The judges, they will not go and download all the datasets and the spreadsheet of all the different companies that create microcontroller sensors and so on. You are the ones that you're supposed to give us exactly what we need for them to evaluate you later on. If you don't have something that they might need for the evaluation, it will not be a good thing for them to try and search for everything. For the GPIO, for example, for the voltages, for how everything it connects to each other, why it's used, you are supposed to give us exactly what we need in these kind of responses. For us, we want to understand the logic mostly. But if we go into the actual implementation and we will not see that you have provided the respective information regarding the need and the connection between the different submodule sensors, microprocessors, etc., it will not be good. So please, when you will submit, make sure you analyze it as if you analyze it here in the webinar, like I do. Uh, so why we wanted all of this to be analytical? Okay, the component justification proves that your team understands the engineering trade-off. So for you to understand exactly how you balance your implementation to do what you want. Okay, not only how to assemble the modules. For us, we don't want to see people that assemble stuff. We want people that they thought why we need this kind of stuff. So let's go to the third part of the reference in the design phase guide. This is the system architecture. This is the software, as we say. This is the logic behind our implementation. So for us, we should show how the hardware will interact with each other, and based on that, what kind of information, data, actions, whatever will happen, will do. So a functional block diagram should group the system into power, sensing, processing, and actuation. Which is power. It's the juice. Let's say it's the kind of it's the thing that every kind of implementation needs to work. Sensing is the input, processing is the mind, and actuation is the output. So these are the basic kind of uh, categories that every system has. So regarding the power, it can be battery or regulator, battery management system. For the sensing, it would be any kind of sensors. And for them, we get input data. Okay, input data. Regarding the processing now, we have the microcontroller unit, MCU, which implements the decision logic of our complete prototype or system. And regarding the actuation, we have the motors and the LEDs. So for us, we can have the kinetic actuation, which is this kind of output, or we also can have electrical just LEDs like lights, screens, and so on, display alarms, etc. Now, regarding the power path, you should show how each module is powered and whether regulation or protection is required. For example, if our microcontroller unit has some kind of general purpose I/O and some voltage lines of 5 volts and our sensor is 3.3, we will need to add the regulator to step down the voltage from 5 to 3.3. And if this kind of sensor uh, transfers a lot of data fast, we might need to protect this kind of transmission of data with a threaded wire or this kind of stuff. If you see it, you will understand exactly what I said. Regarding the data path now, you should show the direction like with lines in your flowchart of the sensor data, the communication buses. So for example, information goes there and there. Based on the kind of communication, it might go one way from one way or the other, or it might go both based on your selection and your microcontroller support and capabilities. And also the control signals. What are the things that they're changing the different aspects of your system's reaction? And then regarding to the output path, you should show the physical results. Movement, as I said before, kinetic result. Alert if it has, for example, a buzzer to do a sound. Display if it's to interact and to show some kind of information to the user. Switching or logging. Switching if, for example, it goes into a bad state, it's better to turn off all the power before, for example, falling into the water. Or logging if you want to keep data while your system is running. So these kind of diagrams, they help the judges quickly understand whether the proposal system or device is coherent, complete, and technically buildable. So uh, for for the for the judges, they should just see that for you, you have thought exactly what you need. Once again, but this time on the logic part. A good thing that you might use, you can use some kind of online like block diagram softwares for you to implement your block diagram logic or the flowchart of your system's logic. Some of them, as I say here in the free tools, is Draw.io or even Canva, which has unlimited stuff that you can do there. And you can use professional logic or electrical shapes to show signal directions, arrows, etc. To make it a little more professional, for to be easier, even with just seeing it, to understand what it is without reading that this is the line that carries voltage, this is the line that carries amperage, and so on. So for us, we want you, if possible, to give us a functional block diagram, which should group the system into power, sensing, processing, and actuation, similarly to what we said before. Let's go now to the software part, one of favorites. Okay, so software design. This is our logic. This is the mind of the system. So we should solve the decision-making logic. How, based on every kind of interaction and every kind of input and output that we see or we get, what we do next. Okay, so the software section should explain how the system behaves during a normal and abnormal operation. This is similar to the example I gave before for the colors. If for us we have only implemented and thought of three colors and a fourth comes, the fourth it's not something that it can understand, so it will just pass it, but it might be useful or it might be something that it will create a, a difference, for example, in function, a difference in movement, and so on. It can we should think of all the different possibilities, and if not, we should put some kind of defaults, like worst case scenario, do this. Okay, so as I said, the software section should explain how the system behaves during normal and abnormal operation. So you might create a flowchart or the design logic with initialization, the starting of our logic. Then we check some kind of sensors. Okay, are they okay? Are they not okay? If they're okay and we can communicate with the sensors, we can go and read the sensor data. Based on what we read, we should validate if the data that we get, they are the correct data based on some other stuff. We make a decision based on that, and then we do an action. Basic thinking of uh, an algorithm. Okay, so what it might be considered a normal logic, sampling rate, filtering, put some kind of thresholds for some values, the movement of an actuator to control it with something, display updates if, for example, we want to print some kind of data as the system is running, And of course, communication if we wanted to control some other devices at the same time. What it might be an error logic, a sensor failure. So for example, a wire can cut off in the middle of your system's run. What happens then? A timeout of a timer, for example. It might be, for example, we don't want for something to stay in a continuous loop because then if that breaks, it will never do anything again. So if we have a timeout, it might be easier for us to detect the error. We should maybe have some invalid data from our communication sensors or from sensors of light, let's say. What happens when we have low battery? Does our battery give us enough amperage for all of the different sub-functions and sub-modules of our system to work? These are stuff that you might need to think. What happens when we lose communication with some kind of sensor? Sorry. Uh, what's okay. What happens if we lose some kind of communication with? Sorry, 1 second. Okay, you hear me now? Okay, good. What happens when we lose some kind of communication with a sub-module in our systems? It might be fatal to not be able to control it furthermore, and it might break on its own if it's, for example, a movement of a motor. Control method. What is the basic state machine that we have? If this do this, if this do this, for example, what happens during a hysteresis, like when we are losing and or when we are reaching some kind of threshold that we can't control anymore. A PID, proportional, integral, and determined scheduling. Uh, Maybe we need to make use of different sensors to get an overall idea of something. This is a fusion. We get different kind of stuff, we combine them together, we fuse them. That's what it means, fuse. And based on that, we do a different action, and we take a different kind of accuracy, and so on. So a flowchart should reveal the intelligence of the project, how the device decides, reacts, and recovers from errors. Very important. You should always think with the errors. If the errors happen, we will not, and you will not have thought of them, you will not be able to control your system after that. Okay. This is, for example, a flowchart where it says based on a temperature sensor. It says start system initialization. Is the sensor okay? Can I communicate with the sensor? If I can't, I enter a different kind of state in my state machine, as we said before, and I try to reinitialize the system. If yes, okay, I read the sensor data, and based on if the data are valid, I recheck and I read again. And if they are valid, I check, is the temperature, for example, greater or lower than this value that I want? And based on the actual temperature, I do a similar or another action. Okay, good. Now, let's talk about money. Okay. Uh, Analytical bill of materials. It will be needed in every part of your life as an engineer. You will have always to talk money with your technical directors, your bosses, your clients, or even your colleagues, where you might collaborate with people from other companies at the same time for a similar project. So for you, you should show in the proposal by providing the project that is affordable. Like for you should say, I use this because it's needed, not because we want it to, and for us to have a spare or for us to have it if something happens. No, everything should be thought well after before you even purchase it. So, for example, in the analytical bill of material, you will not need to add component name, quantity, the unit cost, how much every kind of this component costs. One Arduino costs $28, two costs 56, and so on. The total cost of all the implementation, microcontrollers, sensors, actuators, wires, PCB, for example, solder for you to do the connections, all of this kind of stuff. It should be included in the bill of material. Casting around the system, the outside casing if needed, why it's needed, what is the price of this, what is the price of manufacturing if you pay someone else to make it for you. Very important thing to add also. Short justification. For example, I use this kind of bulb because this kind of bulb it has this kind of thread that we want, this kind of length, and we need it to hold everything together, as an example. And of course, don't forget total cost under 200 USD. If it's more, the the submission it will be a failure. Please don't exceed the $200. So for the ESP32 microcontroller, a cost it might be 6.5 USD, and an analytical justification it would be chosen over Arduino for built-in Wi-Fi and lower power sleep modes. Yeah, that would be a justification. So the bill of materials shows the idea is not only creative, but realistic enough to proceed in the build phase. Like for us, okay, we want to do this. We know we can do them. Let's go and try it. That's the basic idea of it. And now, one of my favorite part, which is optional in general, but for me, I really suggest it, verification and evaluation readiness. So you should finish the proposal by proving the project is testable and aligned with the judging criteria, which means that for the optional verification, you can create some kind of simulation or some kind of mathematical formulas for you also and for the judges to see exactly what you're expecting to happen when you will go and proceed with the purchase of the materials and of the hardware. Uh, Also, you should take into consideration all the different kind of cost that it might create, and you should also kind of think before you purchase, for example, a sensor. You should think, okay, I have this information regarding this sensor. It can do this, but what is the real need of my implementation? If for me, for example, I want to see a distance and the distance is always like 5 centimeters. I don't need a sensor that can read up to 5 meters. This is redundant. So for us, we want something that we need to select something that it's a little more than what we want, but it's the most inexpensive choice based on what we need. So in general, a final check before your overall submission. You should think, can it does understand the problem, the proposed solution, the hardware choices, the software behavior, the cost, and why the idea can work. Or you should think like if you put someone that they don't know your project, can they understand it with your submission completely? When we mean completely, we mean completely. Before even they see it working. For example, you might want sponsors in the future to help you create a startup. If they don't believe the idea, how will they pay you or they will sponsor you to build the physical thing? You need to be um, very good in explaining what you want, and please put time and effort in this. It's very important. So verification will reduce any kind of risk. It shows the idea is not only creative but realistic enough to be implemented. The same things we say over and over and over again. Some basic stuff before we go to the kind of questions that you want to ask me, I want to reply to you, and so on. So for the registration and the design phase of our contest, the registrations began at the 20th of April, and with a small extension, they closed on the 10th of May. From the 18th of May, which is yesterday, up to the 31st of May, you are allowed and you can submit your design phase submission packages on the respective submission form that I sent you the previous day. Of course, if needed, we can send it to you again. No problem. We will remind you in the few weeks that they come. After the design phase finalizes for you and the deadline comes, the judges will evaluate and they will score. They will put score um, to your submissions. And on the 15th of June, for us, we will announce to you whether you pass or not to the build phase of the contest, and thus if you continue to participate in the contest as well. For the ones that they will be selected as the top teams of the contest and they will participate, we will have another similar kind of webinar, but this kind for build phase, where we will, of course, have discussion and any kind of uh, information that might needed for you to get. Uh, just a small reminder again, I know I've said it many times, the maximum allowed cost and for your implementation shouldn't exceed the 200 USD. Although you will not implement it now before the build phase, for you, you should provide to us the expected costs. So for you, you should prove to us that you will not exceed this amount. Regarding now the reimbursements that we say in our rules, the reimbursement is only for the selected teams that they will proceed to the build phase. So for the other teams that they are still in the design phase, for us, we don't expect any physical prototypes to be purchased or created. We just want the idea. So for us, we don't want you to spend money or to purchase any kind of equipment before for you proceeding in the build phase. That's why we say multiple times that you might use some kind of mathematical formulas to estimate if it will work, or if or simulations. Okay, if you have the hardware, yeah, of course you can use it, but regarding the reimbursement, it will only be given to the 20 teams that they will be selected to continue in the build phase, and it will be at maximum 100 USD per team, not more. If you spend less than 100 in general, you will not get 100, you will get the amount that you spend. Okay. Regarding the evaluation and the judging, some stuff that might be of interest to you. As I said before, one of the things that we implemented this year is that we want our judging and evaluation to be exactly 50-50 from academia and industry. We give the different different kind of employment professionals to judge you the opportunities. So for us, we want to be more fair to you. So we ensure a fair and comprehensive evaluation process for all the submitted projects. The judging panel, it will be composed by equal amount of academia and industry for each team, and it will provide balanced feedback, and in general, it will have a lot of steps before the final score. Regarding now core assessment areas that we might think of, like we said in the previous stuff, you might think for the technical merit, what we need to say and to present teams as in the technical part. For example, is this idea feasible? Is this idea something where fixes something? Is it complex? Is it something that it will create more problems or less? And if the complexity is a lot, do we present it and do we execute it well so that the evaluators understand it? And of course, you should think about the feasibility and the realism of what you are trying to implement. Of course, creativity and innovation, it's always a must. It should be your own idea. You should create it on your own. There's nothing starts from zero. Of course, there are some bases where people and every team and every kind of engineer stands on to build more. But for us, we don't want to see exact similar stuff with what it's already implemented, used, or created. Even in previous ITP Arduino contests, please don't. If you participated in the past with the same, don't participate this year with the same idea because they will check. Now regarding the environmental impact, it's always a bonus if your idea has thought of this as well. It will give an extra kind of evaluation in your implementation. Not a major one, but it's another concern that you might want to think when you implement something. So after the evaluation of the design phase, as I said before, up to 20 teams will be selected to proceed to the build phase of the contest. The build phase will initiate, and the selected teams will proceed in building their physical prototypes. Of course, further guidance will be given from our team for the successful submission of the build phase, plus the webinar that I told you about, which will be announced very soon. I think some days before the, the deadline of the design phase. But I will keep you updated. I know you have many questions, and I'm gonna see them now that I will open my Meet on my other screen. Give me a second. Okay, I think I will stop sharing my screen so that I will see them. So stop presenting. Okay, let me see. Okay, let's see the questions. Of course, you can open your mics, but first let's see what you have sent. Okay, meanwhile, uh, I will keep the recording because you might want to hear it later, the response to the questions. I see that before I ask you from which team you are, you responded the country. Okay, it's an option. Um, so let's see. We haven't started yet. Will the slides be shared? Please post session. Yes, both the slides and the recording will be sent to you. For us, it would be much needed for you to see them again and for you to understand very well the rules and uh, and the design phase submission package that you need to send. In general, for us, we want you to do a step where for you will think twice if what you want to be answered it's already available from us through our documents, and then for you to send us your question. Of course, if you don't find the response to your question, you can send us anytime. But in general, if possible, try to see if it's available already in our documents, because as I said, you are 200 teams. So does that mean boards like RDKX5 and the likes aren't allowed, right? I'm not used with this kind of board, but if the cost of this, the retail cost is more than the overall budget, or the cost with other parts of the implementation exceed the $200, yes, it's not right for you to use it. Of course, you can use something more expensive if it's well justified and if there's no better solution. But in any case, even if you have the physical product, the physical thing, and you have already purchased it in the past, for you, you should say the exact price that it has as of now. So in your bill of materials, you will not say, I was given this by my brother. No, you will say this retails with this price right now. Because for us, we should see exactly what kind of costs you spend for it. And even if in a company there's a product that it hasn't been used 20 years, they still purchased it at some point, so it still has a value. So for us, in your system implementation and the bill of material that you will show us all the kind of uh, materials and the hardware that you use, we should see the actual retail value as of now. Nothing should be zero. Let's say it a little more clear. Design phase, right? Yeah. What is the maximum words? There are no maximum words, but uh, a good submission sometimes, if you state clear your idea, it will be smaller than what you expect. So before you even submit, try to read it on your own. Try to see if what you read repeats a lot of times, and if it does, you can see exactly where you do the loop with the same kind of information. Of course, if it's something very complex and needs more analysis, of course you can add more pages. For us, we have a limitation in the pages only in the construction, in the 5-page construction or in the build phase, which will we discuss it when the time comes, or you can also see it in our website. I want to confirm I would be facing plagiarism if I publish a paper later after the same idea for the IEEE Region 8 contest. Yeah, in general, publishing something in congresses, it's not a good idea if you do it in different kind of contests or the congresses at the same time, because if it gets accepted, then it gets, for example, award from another, and then they will have to promote it, and then you will have a problem in the other. So for me, I would suggest you to not promote this, to not give and use the same idea to many kind of congresses. Can ESP now be used? ESP now, I don't know. Let me see it. ESP now. ESP now. Lawless wireless communication. Um, it's a protocol. Yeah. Every kind of protocol can be used in general, as long as for you, you will provide the kind of information we need for us to understand it. For example, if this has a kind of data that it's sent for it to be established, for us, we have to know exactly how this thing communicates so that we can understand the logic behind the data acquisition between your sensors and your hardware. So yeah, everything can be used. And an MQTT protocol. MQTT protocol. Message between climate transport. Okay. Yeah, I guess it's an 8-byte strings. Yeah, I don't think that there will be a problem with it, to be honest. Every every protocol or everything other than the ones that we say, that you should clarify them and you should specify them so that, for example, the judge that they might not know them, they can understand how they work. So why for us we put specific things? If we put specific things in our website, it means that these are the ones that most people they know. If for you you create you use something that it's not very widely available or used by many embedded systems hardware or firmware engineers, it might be a good idea for you to add the dataset or the information regarding this so that they understand it. That's my suggestion. But I don't think there will be a problem, but you will have to state it that we use this kind of protocol because we need this. If you do this, everything will be okay, I assume. Now, yes, Suleiman, please, you have the mic.
Hello, thank you for this informative session. And you clarified all of the points that I was wondering about. But I have two questions. First of all, there has been a change in the team, and one member decided to not participate. Can we change the team structure right now?
For you, what you say to me is that a member of the team doesn't want to participate and you want to add another one.
No, I'm not adding another one. I'm your
Ah,
first.
I think, yeah, for us, we don't want to give more opportunities for people that they haven't participated during the deadlines. But if one team member can't participate or willingly doesn't want to participate, you can send us an email. You can send me an email regarding this issue. And if there is only a reduction of members and not an addition, we're okay. And we will update our data and you can proceed with less members.
Okay, that's clear. Also, should the project be oriented about around uh, the sustainable growth goals, or it can be a commercial product?
The idea and the product that you want to implement in general, all of you, it's up to you. For us, we want to what for you you will create to have a reason of existing. It might be entertainment. It might be
Okay,
something that people
that's
will.
a question.
Yeah, yeah.
It can be anything, and its purpose won't play a role. Like, of course, it has to be to have a purpose to exist, but maybe it's not tied to have a environmental impact, or as you said, it can be a
No,
toy or
for
an
the
entertainment
yeah
product, and it's
for the
and
environmental impact. What I said is that every thought you do behind the preservation and the least amount of energy used is always a bonus. I didn't say that it's the major kind of evaluation. But if you have thought of, for example, even the battery, if you thought how is discharging or how the amperage and the power of the battery is used during the whole cycle of the system, if you have done this kind of calculation or this kind of management of the battery, it's always a bonus. But it's not the major thing of the contest. For us, we want to see the basic idea to be implemented, to have a reason of existing, if there's like some kind of uh, I don't know, rivals from other products that they're already commercially available, it might be better. This kind of stuff. The purpose might be I want to make for example, the most inexpensive game that can do this. That's a valid thing to do. You provide people something less inexpensive. It's something good.
Is the beneficial of the is the importance and how beneficial is the system prioritized over the complexity? So do we have to show our skills building a nice or cool system, maybe for a satellite, or it's
Uh,
better to be simple but beneficial and can be used and employed in more frequently?
yeah, that's a good question. Regarding the final form of the project, if proceeding to the build phase, because we are talking about prototypes, we don't really care about the overall appearance. It can be rough sketch and everything, but if there's a reason for it to have a cover because it should hold sensors, we don't want it to be the smoother cover or whatever. We want it to work. So the appearance and the overall aesthetics of the final product, they don't matter in this phase because we are prototyping right now. When we go to the part where we commercialize something and we fine tune it after we see that it's already working with specific stuff, then we are talking about aesthetics and form over function. But it should never be form over function because if the function is not good, then the form it doesn't matter a lot. So for us, I would say to you, prioritize the implementation to work well, not the aesthetics.
Okay, that's all clear. Thank you very much.
You're welcome very much. Mohammed, please.
Hello. Thank you so much for this informative session. I just had one question. If my project calls for multiple microcontrollers, would that be allowed?
If you can support the need of them,
Uh-huh.
yes, it's allowed. And if it's under the maximum amount of budget that we have set, of course, it's allowed for you to implement it. But for you, you have to have a real reason why you need more than one. So you have to state it.
Yeah. Thank you
Yeah,
so
that's good.
much.
You're
Thank you.
welcome. Uh, I hope I pronounced it correctly. Sikamso, Hikamso Izunobi. I hope.
Yes, yes, that's my name. Okay, thank you for this. I wanted to ask if we had like an accident, like let's say we burnt through one of our components and had to get another one, would that factor into the cost, or the cost is just what we used, what is in the prototype at that
Uh,
point?
uh, for you, well, because I think I had some stopping in my streaming. For you, what you say that if something broke during the implementation, if when you buy something else, it's added in the budget.
Yes, is it added or not?
No, no, it's not because you, because after you will learn how to avoid the mistake, you will not need it. So it will not. So the ones that they will try to reproduce it or to replicate it, they might avoid the mistake that you did when you implemented it. So for them in the construction, they can use only the things that you said in the beginning without the extra after something broke by accident.
Okay, yeah, thank you.
You're welcome. Uh, is there someone else that has some kind of questions? I had some questions in the forum. Let me remember them. Okay. So a participant asked, I want to ask regarding the project scale and categories, what could increase chances for passing the design phase? In general, it doesn't matter if something is the most complex thing to implement or the most complex thing to do. It matters for an idea to be well thought after and to solve a problem, to have a reason of being implemented or to be created or to exist. Some kind of problems they might be difficult, but they might need simple solutions. So if you find a simple solution that solves a problem in general that no one has ever thought, that's the best possible scenario. Less complexity, less budget, less hardware, more sustainability, easily serviceable. This is a plus. Uh, the one thing that it might be bad is to make something more complex than it's needed. So for you, before you implement your algorithms or your design logic, it's a good idea to think if the extra step that you thought it's really needed for what you do, or the extra sensor it's needed, or if you want to use it either way, you should support it. And what by that I mean, you should support it to the evaluators why you use them either way. You can say because we have to be 100% accurate for this because this danger will uh, will be very catastrophic for our system. So yeah, everything has a reason as long as it's being supported. If it's not being supported, it might be it might add complexity if not justified. So for me, I told you, I want all of you to take a step back when you submit before you submit and read it on yourselves to see how complex it sounds to you, or if you can avoid some of these steps. Will the recording and the slides be sent to our mails? Yes, they will be sent, but in the following days. I don't think it will be done today, but in the following days it will be done. Before we send them to you, you have everything that you need for you to implement everything and to see again what we discussed in our website, in our rules, and into our submission design phase submission. We have design submission phase guide. You can see this. It says the same thing. Is it compulsory to solve the codes used in the microcontrollers? As of now, in the design phase, if you read the rules, please do, all of you, again and again. I might forget them also. You don't have to give to us and to submit your source code. For us, we want to see the design logic as an algorithm, as a state machine. If else or what, exception, this kind of stuff. For the build phase, where it's the part where everything as a product is being judged, for us, we want to be capable of implementing them on our own if needed. I don't say that we will do it, of course, for 200 teams or 20 teams, but if needed, we have to be capable of replicating everything that you have created. So the code that you have run, that you have wrote, we might need it to program the device to see if it works. And the judges might want to see if the code that you write, it's yours or it's not 100%, for example, Claude. It can be part of Claude. I said you can use AI tools, but every piece of code, it should be purposeful for you to understand it. For you, for example, you might be lazy because all people are at some point, and you want to say, write me this LED to get on every 2 seconds. Okay, you do it. It's called Claude generated. It might not be detected even from us, but every kind of code that you write, it must have a purpose. So a nice structure in the code also, it would be a plus. I'm just saying it only helps to give the code. It doesn't make it worse. And that's why we ask it to help you in the final evaluation for the build phase. Could we update the team name in the design phase submission? About that, for everything that you might need to update the team name, you can send me an email. It will be the final time because you are 200 teams. If they update the name every day, we will never finish with it, and it will be final. It will never change again. And regarding the team members, I said if there are team members that they willingly want to not participate anymore, send me a personal message with this team member, so that we can see that they don't want to participate willingly, and for the team to have one less member if that's what you want. So regarding the team name changing, okay, you send me a message, we change it final time. Regarding the team name members, we can only remove, not add, because if we could add members, we should add another kind of form for all the people that they didn't participate in the registration in the normal one. That's why we don't add more. Not because we don't want more people. Can mechanical design model give extra points in the design phase? Only if well justified, and there's a reason behind the form of the mechanical construction that you will make. Yes, but we don't want the the best of, for example, tolerances and stuff, because unless it's needed. If you justify the need of high tolerances, bravo to you, congratulations. They will understand it also, and they will give you extra points. But if not, we request the electrical, the mechanical, and the mechatronics, the software, everything that you will implement during the build phase. On the design phase, we don't need it. In the design phase, we want to see the general idea of the system that you and the project you want to create. So if you create something that it's awesome mechanically, but it doesn't have a lot of purpose to be awesome in the prototyping phase, it will not be bad to do it. You will not get less, but I don't think you will get much more either. I don't know if that helps somehow. Is there someone else with a question? Okay. So let's do if the system has multiple modules like a wirelessly network for systems, is that allowed? Again, if your implementation, your project needs of separate kind of processing units, if you justify the reason why it needs this, you're allowed, as long as you are in the budget. If you exceed the budget because of that, the design phase submission, it will not be valid because this is one of the requirements we put. Also, if there's another way of implementing what you implemented with a single microcontroller, it's not very good also. So before you add the complexity and the other components, see what you can do already with the simple stuff. Is there another question? Okay, just a summary. Please follow the deadline. We will not exceed the deadline this time because we are going into June, and then we will go to July for the building phase, and we have to do the finals, which we will announce to you when they will take place. Please be very mindful to look very well at your submission deliverables, the documents that you will send, the formatting, the project name, the team name, everything regarding the presentation of the team, it should be there. All the team members, they should be announced and described in them. If we see a team with one or more members to not be described, it could be very potential disqualification. Please, you should announce and you should describe every team member inside your decision in the design phase submission. Please state all the kind of costs and the materials that you will use. Show us your design logic. What is the algorithm behind your implementation? What is the need of your projects? What is the problem that it's trying to reduce or to eliminate? It might be to create enjoyment. If that's what it is, you should state it. Regarding now the meeting and the slides, they will be sent to you not today. They will be sent to you in the following days. Not a lot, but not today. Also, this webinar will be also available for you to watch it online because it's part of our team. So that's all from us. If there are no other questions, I don't see something else. I would like to thank you all again for participating into our contest. And again, congratulations for you for proceeding into the design phase of our contest. Thank you again for participating in this webinar. I really liked your questions and the discussion we had. Please, before thinking of sending any kind of questions to us, please try to see if they are already uploaded in our documents and our website. There's no need for extra traffic in our emails if we have already stated this kind of information in our official documents. Of course, if something is not, please feel free to send to us. We will reply to you within hours. Yep, that's all. Take care. Good luck to you. Design twice, build once. Take a lot of steps back, think again and again and again, and try to support your opinions and your decision choices. Good luck to you. Good night to most of you. I think in every country it's starting to be late. And see you in the next webinar for the ones. And also, whatever you might need, please don't feel bad, or please contact me. I don't have any kind of restrictions. If you need me, I'm there for you. So good night to everyone.